Hello and welcome to QuNav. We're dedicated to transforming navigation technology to enhance safety and autonomy. Today we'd like to share one of our technical projects for the Naval Information Warfare Systems Command Platform called GIDI-UP. At QuNav, our mission is to develop advanced navigation technologies designed to maintain accuracy and reliability even in GPS-challenged environments. Our solutions support autonomy, safety, and consistent performance, regardless of conditions. We were founded in 2011 and have since built a strong IP portfolio through over $19 million in non-dilutive SBIR investment. Our technology is transitioning to practical use through strategic partnerships and software licensing. Our customer and partner base includes the Air Force, Navy, Army, DARPA, and the Missile Defense Agency. Major industry players that work with us include Northrop Grumman, Honeywell, Telit, U-Blox, Bosch, NextNav, Supernal, Javad, and Fugro. GIDI-UP stands for GPS Interference, Direction of Arrival, Initiative for User Purposes. It's a mouthful, but at its core, GIDI-UP is all about navigation in contested locations. In any environment where GPS signals are used for navigation, bad actors can attempt to interfere or jam those signals, causing safety and security concerns for both military and civilian activities. The Navy's objective with the GIDI-UP program is to develop a direction-finding sensor to locate and neutralize the source of GPS interference. The goal is to provide real-time situational awareness of jamming and spoofing signals. The system must be able to estimate direction of arrival, or DOA, with less than 1 degree accuracy in both azimuth and elevation, ideally down to half a degree. It should also be able to estimate DOA for up to 6 distinct interference sources and log the records for each detected interference event, including uncertainty metrics. The main transition target for this capability is the GPS-based Positioning, Navigation, and Timing Service, or GPNTS. Navy vessels today are equipped with controlled reception pattern antennas and military GPS user equipment modules for anti-jamming and anti-spoofing defense. These feed into the ship's bridge and combat systems through GPNTS. What is missing is a dedicated system for situational awareness of the GPS spectrum itself. That's a critical gap, especially in complex electronic warfare environments. Our solution to this challenge is QShield. QShield uses a cascaded architecture to simultaneously protect GPS signals from both jamming and spoofing. It starts with pre-correlation mitigation of jamming, estimating the direction of interfering signals, and using null space projection to suppress them. After that, post-correlation spoofing mitigation kicks in through beamforming and signal tracking. The beauty of this architecture is that DOA estimation becomes a byproduct of GPS protection, giving us both electronic protection and support. And while it integrates naturally with GPNTS, QShield can also be applied more broadly across military navigation systems that need robust protection and situational awareness. QShield is designed as a software add-on. One of its key features is codeless estimation, which means it can detect threats to secure military signals like M-code without needing access to the correlation engines for those secure channels. The system works in 2 stages. First, a pre-correlation module detects and suppresses jamming using null space projection. In this technique, the received signal space is mathematically decomposed, and the projection is made onto the subspace that is orthogonal to the interference direction, effectively removing the jammer while preserving the spatial structure of the authentic satellite signals. This allows the system to maintain valuable angular and timing information for downstream spoofing detection. Second, 2 spoofing mitigation modules then operate in parallel. One uses PRND spreading when known. The other uses spectral compression for unknown PRNs. If military GPS user equipment, inertial navigation systems, or GPNTS are available, they further improve spoofing detection. So where are we today in terms of development? We've built a hardware prototype that's M-code compatible, featuring a 7-element controlled reception pattern antenna and a mobile data recording and test platform. We've also developed and validated a software prototype using test data. It meets the performance requirements for civilian GPS signals and shows strong promise for secure military signals. M-code validation is ongoing. Here's what QShield delivers. It enables situational awareness in complex RF environments by estimating the DOA of both jamming and spoofing threats. It fills a gap in GPNTS and other systems that currently lack this capability. Our DOA estimation accuracy meets the half-a-degree requirement in both azimuth and elevation. And importantly, QShield can be added as a software upgrade to existing military navigation products. In order to transition QShield to the fleet, we'll need continued support of our network of warfighters, technical stakeholders, and technology integrators. Our Phase 2 goal is a TRL-6 prototype. We're seeking Phase 3 funding to further mature and integrate QShield into GPNTS. Our transition advocates include Navy Program Office PMWA 170 and GPNTS prime contractor Raytheon Technologies. Beyond the military, QShield addresses commercial needs as well, especially in safety-critical applications like advanced urban air mobility, autonomous vehicles, or protection of critical infrastructure. Our go-to-market strategy includes live demonstrations, partnerships, and software-based technology insertion. At QuNav, we invite collaboration. Whether you're interested in deployment, integration, or testing, we're ready to talk. Reach out to our team today for more information, and let's make GPS failure a thing of the past.